firstly looking at question number 10, where the question asked you to square the binomial x plus 6 squared. One of the answers I saw walking around was x squared plus 36. Did anybody get something different? Or we got x squared plus 36?
I got x squared plus 12x plus 36.
X squared plus 12x plus 36. So if I took a vote right now on which one of these is the correct answer, I can assume I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 people voting for this option and one person voting for that option.
I got x squared. I got that.
Oh, okay, all right. So we do have some dissension here. So let's turn that to 11 and 3 instead of 13 and 1. Okay, so Bridget, tell me about your answer.
I foiled I put x plus 6 and then x plus 6 together and I foiled them.
Okay, so you foiled. All three of you foil? How did you foil in this problem? It doesn't look like there's anything to foil. Sierra?
Because with the exponent on the outside, that means that you're doing x plus 6 twice.
Uh-huh. So you went directly back to the definition of what it means to square something. What does it mean to square something? Multiply it by itself. I don't think anyone can argue that x plus 6 squared, quantity squared, is not the same thing as x plus 6 times x plus 6. That's what it means to square something. And when you rewrite it that way, you turn it into a FOIL problem. And when it becomes a FOIL problem, I'm going to use the lattice technique here to do out the foiling. You know, you can use whichever technique you like, x plus 6, x plus 6. You end up, after multiplying, with an x squared, with a 36, and with a couple of extra terms of 6x in them. So that when you add all of these terms together, the two like terms, the 6x's, get together and give you a 12x to throw in with your x squared plus 36. So that's one way of doing this problem. Somebody from the majority, x squared plus 36, you want to tell me about your answer?
I just distributed the exponent.
Okay, so you just took the exponent 2 here and went this way and that way and turned it into x squared plus 6 squared. Okay, which undoubtedly is equal to x squared plus 36. So of course now I have to ask, can both of these be right? How do we know they can't both be right? Yeah, the two expressions have different values, right? Pick any value you want for x, almost any value for x. The value that x squared plus 36 has is going to be different from the value x squared plus 12x plus 36 is going to have. So they can't both be right. Which one of them is more likely to be right? One of them uses the definition of what it means to square something and then FOIL. The other distributes. So what's the problem? Let me pass judgment first and congratulate the 3 gutsy of you who rewrote as a product instead of a power and then used FOIL. Because after all, again, no one can argue that squaring x plus 6 is not multiplying it by itself. That's what squaring means, right? So that has to be right. Which means that the distributing, which by the way is such a common impulse, the majority of you did it. And the majority of every algebra class I've ever taught when this comes up does that. You want to distribute because distributing happens so often and it's so helpful and it gets rid of parentheses and it makes things simpler in so many cases. So why doesn't it work here? What's the red flag that should go up when you look at this expression that should tell you don't distribute? How are you going to avoid that mistake? Because I can promise that it will be on the next exams here.
Is it because what you would be distributing isn't like in the front, it's like
Yeah, so the big difference is what's happening to the quantity in parentheses. So here x plus 6 and the 2 is on the outside. What operation is that 2? What is the operation connecting that 2 to the parentheses? What would you describe that as? What is that 2 actually doing? Or maybe let me focus more closely on what Sierra just said. what is the difference between putting the 2 there and putting the 2 out here? What's the difference between that and that? One's an exponent, and the other is what? It's a coefficient. It's multiplication versus a power. So much algebra confusion has at its root a confusion between multiplication and taking a power of something. Right? They're not the same operation, even if one is built off of the other. Just like multiplication is built out of addition, taking a power is built out of multiplication, but they are not the same thing. And so we can leap this 2 if it's a multiplication over the addition. And that's okay. That's totally fine to do. That's the distributive property of multiplication over addition. But an exponent cannot be distributed across addition. So one of the ways that I like to keep this straight, as I so often do, is to go back to my layer cake of arithmetic operations. Here it is. And when the question is what operations distribute over what, it's a question of adjacency on this diagram. Multiplication on the outside of parentheses distributes over addition on the inside. That's totally fine. That's the property that we just used on the top. So that pair distributes. It's also true that powers, and this is something you use in question 13, distribute over multiplication. Distributes. This is how you got started on question number 13, which if I can quickly jump forward just to show you what I mean by that. In this expression up here at the top, the first step in your process was to distribute the power of 3, which is outside the parentheses, to each one of the 3 multiplied factors that's on the inside of the parentheses. That's okay because it's an exponent distributing across multiplication. Because they're next to one another on the layer cake, they distribute. Likewise with multiplication and addition. They're next to each other on the layer cake, so they distribute. But exponents and addition are too far apart. On our layer cake, exponents are way up here. Addition is all the way down there. Those operations don't distribute. So if it's a power on the outside and addition and subtraction on the inside, no go. The only way forward is to rewrite it as a FOIL problem. And when you rewrite it as a FOIL problem, then everyone knows what to do with it. So when people screw that stuff up, it's because they forget to write it as a FOIL problem instead.